Hi, Mr. X with glossary term arc length. It's any curved length. It doesn't have to be a piece of a circle, even though most of the time when we encounter arc length it will be a piece of a circle. But let's be clear, it doesn't have to be a circle. In calculus we could have any sort of curve defined between A and B, and then we can calculate the length of that curve if we know the function, if y is a function of x. Okay, we'll talk about that another day. Most of the time when we talk about arc length, it's about a circle. And we can picture it like that. What's the arc length between B and C? If we know the angle CAB or BAC, can we then calculate this arc length? And the answer is, sure we can. Now let's assume, for our purposes, that this is a 70-degree angle. Might be 75, but we'll just use 70. So what is that arc length BC? Well, some people would say arc length BC, and they may use that notation, would be equal to the part of the circumference that we've used. So the circumference would be 2 pi r, that's always the circumference, or if you like, pi times the diameter, and we would multiply that times the part of the circle that we've used. So we could think of it as times 70 over 360. 70 over 360 reduces to 7/36. So let's do a quick numerical calculation. Let's suppose the radius is 27 units. 27 centimeters, 27 miles, 27 inches, whatever it is, it's 27. So that would mean that AC would be equal to 27, and that would be also the measure of AB. That's our radius. There's a lot of ways we could say that. What is the arc length BC? 2 pi r times 7 over 36. That would be our arc length. The 7 over 36 is just the same as 70 over the 360. That's how many degrees we've used. So that's the fraction of the circle circumference being used, 70 3/60. It's a good way to think of it. We could clean this up a little bit. Let's see. 9 goes into there 3 times, 9 goes into there 4 times. I think we're left with, oh, and 2 goes into 4 twice. So what we're left with is 21 pi over 2. Or 10.5 pi would be our arc length.